Hi, welcome to Learning Monkey. I am Raghu here. In this class, we'll discuss about bounded, unbounded and complemented lattice. In our previous classes, we clearly discussed about lattice and its properties. Please watch those classes and come back here. The link for the playlist is provided in the description below. Coming to today's class, so before going into bounded and unbounded lattice, first we need to understand what is meant by upper bound and lower bound. Let's take a lattice. This is the example which we are going to use, which we used in our previous classes. So the element 18, we call it as upper bound. And the element 1, we call it as lower bound. Why we call this element 18 as upper bound means, so you consider this element, you take all the remaining elements. All the remaining elements should form a relationship with 18. Then we say it as upper bound. See here, 6 relates 18, 9 relates 18, 3 relates 18, 2 relates 18, 1 relates 18. So the relation symbol here is divided by. Hoping that you already know how we got this lattices. So the upper bound we call it as I and the lower bound we call it as O. So this is the upper bound and this is the lower bound. Now coming to the bounded lattice, if upper and lower bound exist, we call it a bounded lattice. In a lattice, if both upper bound and lower bound exist, then we say it as bounded lattice. The above example is the example for bounded lattice. Now coming to the unbounded lattice, if lower and upper bound not exist, then we call it as unbounded lattice. Let's take an example. What is unbounded lattice means? Let's take the lattice L is equal to I comma less than or equal to. I means here set of integers. On the integers we are going to apply the relation less than or equal to. So the diagram, the hasse diagram looks like this. I means integers means minus infinite to plus infinite. So minus 2 less than minus 1, minus 1 less than or equal to 0, 0 less than or equal to 1, 1 less than or equal to 2, go on up to infinite and up to minus infinite. This hasse diagram do not have a upper bound and it do not have a lower bound. So it is unbounded lattice. So now coming to the next example, before going into complemented lattice, first we need to understand how to find the complement of an element. You take a bounded lattice, so complements apply only on bounded lattice. You take a bounded lattice. This is a bounded lattice, upper bound and lower bound. So upper bound we call it as I and lower bound we call it as O. You take any element. Let's take an example 2. What is the complement element of 2? 2 is 9. 9 is complement to 2 and 2 is complement to 9. Why? When we call it as complement elements? See, least upper bound of 2 comma 9 is 18, which means I. And greatest lower bound of 2 comma 9 is 1, which means O. You take a pair of elements. If the least upper bound is I and the greatest lower bound is O, then we say that those two elements are complement of each other. So complement of 2 is 9 and complement of 9 is 2. Now coming to the definition of complemented lattice, if you take a L means lattice, this is the symbol for least upper bound, this is the symbol for greatest lower bound, O means upper bound and lower bound, is a bounded lattice. If you say this L is a bounded lattice, then a bounded lattice is said to be complemented lattice if every element is having a complement. You take any element, it should have a complement. If that happens, then we say it as a bounded lattice. Then we say it as complemented lattice. Now let's take an example. Let's take a L is equal to 1, 2, 3, 6, 7, 14, 21, 42. These are the set of elements. On this we are having a relation divided by. If you draw the hasse diagram for this is how it looks like. You do it on your own how to construct the hasse diagram. So it is having lower bound and greatest, this is the upper bound and this is the lower bound. 1 is the lower bound and 42 is the upper bound. So this is I, this is O. If you take any element, it should have a complement. If you take 1, 142, What is the greatest lower bound of 1 and 42? Which is 42. What is the least upper bound of 1 and 42? Which is 42. What is the greatest lower bound of 1 and 42? 1. So I, O. So the complement of 1 is 42. Complement of 42 is 1. Similarly, 2. If you take element 2, 2, 21, 42. 2, 21, 1. So the complement of 2 is 42. The complement of 2 is 21. Complement of 21 is 2. Sorry here. So here we have written the mistake. It's not 42. 2 complement is 21, not 42. 21 complement is 2. Similarly, if you take the remaining elements, the complement of 3 is 14. Complement of 6 is 7. Complement of 21 is 2. So you are having all complement for all the elements. You try to do it on your own. You take any element. If you take 6, you need to identify a complement element. Means something 6 and 21. If you take it as a least upper bound means 42. Greatest lower bound means 3. So it is not the complement. 6 and 14. You consider this. Least upper bound is 42. Greatest lower bound is 1. No, it is not 1. So you are having 2. So it is not the complements. Like that you have to check the remaining elements. All the elements you are going to get, it is a complemented lattice. Hope you understand the definitions and examples. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.